Hey viewer, welcome to the channel Code with AD. This is video number 2 and mm, our second project from machine learning project series. In this video, we will be creating a classification model that is human personality prediction model. So first of all, let's check out the problem statement. So yeah, here is our problem statement that states, can we use machine learning to predict a person's personality type, extrovert or introvert, based on their personality traits, habits and responses from a survey data set. So basically we have to create a machine learning model in which we will be given some personal traits of a human, then habits and responses, and that will be a data set. So yes, we can create that machine learning project, and in this video we are doing so. So now let me walk you through the project overview and break down how we will execute the code step by step. So these are all the steps which we are going to follow in our this video. So first step is EDA, that is exploratory data analysis, in which we will load our data set firstly from Kaggle and then load in our Google Colab. And in EDA, the second step we will do will be understand each feature and analyze them using graph, and for that we will use a library like Matplotlib and Seaborn. And the next one is and then we will know the relationship between features using Pairplot and correlation heat map. And then after this, the next step come, that is data pre-processing. And in this step we will be doing three parts. The first one will be the encoding our categorical features if there will be any in our data set, and then we will handle any missing values if they will be present, and at the end we will split our data set into train and test data. And after the completion of the second step, we will move to the third step, in which by analyzing our data set we have been considered a algo that will be used in generating the model for that. So in this step we will generally create our ML model. And last but not the least, our fourth step will be the prediction, where we will make prediction on our test dataset using the train model, which is based on any algo that will be used. And then we will do analysis of result through classification report and confusion matrix. So first of all, I will take you to the Kaggle website and our data set. So yes, this is our data set, extrovert versus introvert behavior data. I will pin down the link of this data set in description box, so you can check that out and code with me hand to hand. And let's take the overview of this data set. So here are these features like time spent alone, hours spent alone daily, the value lies from 0 to 11, likewise post frequency, drained after socializing. These are the features we will look forward. And the file we will be getting is in the CSV file. And here is more about the data. These are the columns which we will be having, and this is the some description about the data. Now we have to take this data. So first of all, we will click in this download button, download the zip file, and from zip file we will extract our data set. And then we will move to our Google Colab, where I have already opened my Google Colab. You can use also Jupyter Notebook. And Google Colab is just a cloud based Jupyter Notebook, but you can also use the Jupyter Notebook. And from here you click here, and here will be a logo to upload your files, therefore upload your CSV file. And let's start our coding. So first of all, we will be importing our classes, libraries and modules. So I will write import pandas spd. So basically this library, that is pandas, is very essential in data science because it deals with the files like CSV and other. So yes, and then we will be importing matplotlib dot pyplot spld module to plot some graphs like count plot and other things. And in the top of the matplotlib we have to also import Seaborn library, which provides us a very good visualization in our dataset as SNS. Then we will import what we have to import. Yeah, so from sklearn dataset, sklearn class, we will be using pre-processing. We will import from here label encoder to encode our data. Sorry. And then from sklearn dot model selection, we will be importing train test split, so that we can split our dataset into two parts, that will be train and test dataset for further use in model building. And at the end we will be importing sklearn dot metrics import classification report accuracy score and confusion matrix. So basically when our model will be created and we will do our prediction in test data set, then we can understand and see the report accuracy score and other things through these three modules matrix. And now we will run this using pressing control plus enter. Yeah. Okay, so our first cell has been executed without any error, and we have imported these many modules. Now what we'll do, first of all, what we have to do, our first step is to perform EDA, exploratory data analysis. Yeah. And then, so for this we will take our data frame as df, and we'll do pd dot read csv. Since we got personality dataset dot csv file, so we will be reading the read csv method, and we will just personality dataset dot csv, and let's check the first 5 data. Okay, so we have made any error here. Read, okay, here I haven't written csv. Now it will run oh sorry, small bugs. Yeah, so here is our data. You can see that we got time spent alone. As we have seen our data set, these were our features. So time spent alone, stage fear, and same you can see here that time spent alone, stage fear, social event, attendance, etc. So yes, and this is our target column: personality, extrovert, introvert, like this. So first of all, what we will do, you can see that here we got two categorical columns features: drain after socializing, that has values of no and yes. Likewise, stage fear, that is also in the terms of no and yes. And there is another categorical column, that is personality, extrovert and introvert, but it's an target column. So that's why we will keep our target column in separate variable. So no, I don't need this. Yes, we will delete this cell. Yeah, so what we will do, we will separate our columns, separate columns. So numerical calls, these will be time spent alone. It's time consuming. What I will do, I will just copy and paste from here. That will be an easy task. Yes. Okay, so it's not a numerical column, so we will replace from social event attendance, and then moving to another one, going outside, then no drain friend circle size. Yeah, it's time consuming, I know. And at the last, post frequency. This post frequency means the number of post a person make in social media, that is the post frequency here. Yeah. Now the categorical columns. So for that, what we will take stage fear, and the other one is trend after socialization. And here the trend after socializing refers to when a person comes in a social event, and when he or she loses a lot of mental and emotional energy, then he get drained out. And this is what is referring here, that when a person get drained out due to a social event, so then the value will be yes, and if he is not drained out, then the value will be no. So through this, you can get here that a extrovert person never get drained out in a social event because of any emotional or mental energy loss. So it's a good factor for extrovert people. And here we got the target column, and the target column will be personality. Yeah, here we go. We will run this cell and move to the other cell. Now let's see the basic information of our data set. We have separated our column. Now what we have to do, we have to see the basic information of our data set. So here what we'll do, basic info. So print, let's check the shape of our data. By the way, I have previously shown you the shape, but let's check here out, and then we will also see the information of our data. Yeah, so you can see that the shape of our data is 2900 comma 8. That means 2900 rows, or we say entries, and 8 columns features. And if we go to our data set, it is already shown us that the data set contains 2900 rows and 8 columns. Now moving further, when we look into the information, you can see that we got 2900 entries, okay, 0 to 2899. But if you look into time spent alone, we got only 2837 non-null, means there are some missing values. Likewise, stage fear also has some missing values. Social event attendance also has some null values. But when you look into the personality, the target column, there is no missing value. That's a good sign for our data set. And we will also deal with our missing values, and for that we will be using simple imputer uh, to handle the missing values from our data set. And moving further, let's see, first of all let's check how much missing values we have. Okay, checking total null values. So what we do, df dot is null. This is the function, and we'll sum of all of them to get a exact value. Yeah, so here you can see that the time spent alone has 63 missing values, stage fear has 73, likewise drained after socializing has 52 null values, means missing values. But the personality has 0 null values. So next thing what we will do, uh, yeah, we next thing what we'll do, we will check the unique values for each and every column we have. So for call in, I will just show you for the categorical column, because we will be only looking into the missing values, are we going into the right path or not. That's why I'm showing you this categorical calls. From this we will get the call print f unique values in where, in the column. We use colon, and then what we'll do, we will print for df call. In this particular column we will see the value counts, and we have also want to see the missing values, the number of missing value. That's why we will put drop na, means we will be not dropping na, we will make it false. We are not going to drop null values. And let's execute it. Yeah, so for a categorical column we were having only two features, that was stage fear and drained after socializing. So stage fear has three values: no, yes, and nan. That means missing value. No, no got 1417 entries, yes got 1410 entries, whereas nan means missing values got 73 entries. And if you go above the stage fear, you can see that the null values, the number of missing values here was also 73. So yes, we are looking into the correct path. And let's create a new cell and move further. Now what we will do, we will be plotting some plot graphs, so that we can understand the understand and analyze our data set, our features, so that we can know model we are going to use further for our prediction. Yeah, so plt dot figure we will be using, so this will create a new figure for our plot. And we will take 10 inches and 6 inches sns dot count plot. We will be first of all seeing the count plot to know the class distribution in personality. Okay, so what it will do, it will take the target column in the x-axis, and data we will be taking from our data frame. Then the title of what we should take the title, yeah, we will take the title as class distribution of personality. Then what will the x label, in x-axis we will be writing personality. Then for y label we will be writing count, so it will tell the count of extrovert and introvert. Here I have made a mistake, it's plt. And now we will see our plot. Yeah, so this is our plot where I have made a mistake. Okay, here I have to write not figure, it should be a fixed size. My bug, yeah. So here you can see that extrovert and introvert, these are only two unique values in our personality target column. And extrovert got more than 1400 entries, whereas introvert got approximately 1400 entries, which is lesser than extrovert. So yes, there is an imbalance in our target column, but we can ignore this imbalance in our target column methods through which we can do that. So right now you have seen that the count plot of personality. Now moving further, okay, yeah, now we will be plotting a box plot to understand different features and how they are related to personalities. Okay, so plt dot figure, and the figure size we will be taking 8 by 6. Then for, sorry, for I comma call enumerate. So enumerate is an inbuilt python function which provide us to loop, and it also provide to get an understanding about the index. Okay, enumerate, and first of all we will be taking the only numerical columns we can uh, plot the box plot, comma I, no, we will be starting from 1, our index will start from 1, and yeah, here our loop starts. Here we will be plotting plt, there is a mistake I have to put in plt dot subplot. There will be a subplot and we will be taking a grid of 3 comma 2 comma I will be keeping an eye on each subplot so that they can be plotted on their index number. Then sns dot box plot, we will be using the box plot, and x equal to target call, and y will be the particular column, and data will be using from data frame hour, and plt dot title will be f column by personality. Yeah, here should be any space, and next thing will be plt dot tight layout. These functions help us to do not overlap the subplots. Through this the subplots will not overlap each other. Yeah, and now plt dot show, we'll be running this code, it will take some time. Yeah, so if you have seen that we got 5 numerical columns, 1 2 3 4 and 5, and likewise we got 5 box plots on by personality. So if you see the first one, time spent alone by personality, so here you can see that less time has been spent by extrovert people, whereas the introvert people has spent more time alone. So yeah, it's an common trait in introvert that introvert people spend more time alone, but each and every box plot has some outliers. Like here in introvert we got every box plot has some outliers, and that's why these can be also data entry error, but it is also there are chances that these outliers can be and valid, can be the valid points. Okay, so for that if we will be using logistic regression, then we have to deal with our outliers, and if we don't want to deal with our outliers, then we have to use any tree based algorithm. So I think we should use random forest in our model here. Okay, so yeah, we will be using random forest for our model training. And I will show you the friend size also. Let's say a friend circle size, extroverts got more friend circle size whereas introvert got lesser, and yeah, going outside extroverts has higher number, introvert had lower number. Post frequency also is in the favor of extroverts as compared to the introvert. So you can analyze on yourself also that and you should analyze these graphs on yourself, so to make your understanding more powerful. Yeah, now let's first of all plot pair plot on our key features. For that, what will we do? We will do sns dot pair plot, then df numerical calls, and here I should also add the personality plus target, that is our target column, and in hue I will be using the target column because our whole sorry, our whole pair plot will be based on our target column, and the diagonal kind will be the hist. Yeah, diagonal kind will be the histogram. Yeah, plt dot subtitle, what should be the subtitle? Subtitle will be pair of numerical features. Now you will be thinking that I'm not making any plot on categorical columns, because that is not needed here, and mainly numerical columns are used for plotting in training our models. Numerical features by personality. Yeah, and at the end plt dot show. Let's see our graph. In pair plot it takes some time to plot. Okay, I got some error here. The error, numerical calls plus target call. Yeah, why the error has been. Okay, I have written here sub, but it's sub. Now it will work correctly, and there will be no any warning or error, and our plot will be plotted correctly. It is taking little bit more time because of my remote location. The internet is not working so well. Yeah, here is our plot. I can, is there any way to show you in a bigger picture? Yeah, this is our whole plot. Okay, so if you can see that blue refers to extrovert, and orange here refers to introvert. And if we see, first of all, in pair plots, it is the first step to see the plot diagonally. Okay, so first of all see the plot diagonally. So if you see that uh, extrovert create spend less time in alone, whereas the introverts spend more time alone. And here you can see social event attendance, extrovert are attending more. As you can see that 3 plus 3 6 uh, his are for extrovert, and only 4 are for introvert. And yes, it is also obvious because introverts spend more time. That's why here you can see there are more hist for introvert personalities as compared to extrovert. And if and the second step to look into the pair plot are non diagonally, means off diagonally, like seeing here here. So if you will check for social event attendance and time spent alone, so this can be the plot, and even this is also the plot, is the just the transpose of each other. So here you can see that uh, those who uh, spent less on social event attendance here, those are introvert, and they also spend more time in alone. But here you can see two of the points are for extrovert, and these are just outliers. That's why I'm saying that we will be training our model on based of random forest, because random forest is very quick to understand outliers, and we do not need to use any external methods to counter these outliers. And likewise you can check the whole pair plot. It is impossible to uh, and make you analyze that how to read this complete pair plot, but it's my request that you should understand this and work on the pair plot to make your understanding more good. And yeah, now let's see a correlation heat map on the numerical features to understand that which numerical feature a is reciprocal to another one, and which is parallel to the other one. Okay, so here we will be using correlation heat map plt dot figure. EDA takes some time. Okay, you have to be consistent, and also you have to give a lot of time in EDA to understand the plots, and be comfortable with the plotting. Then only you can understand the dataset completely, and you can train your model in the best way. Calls dot core and not will be true. Here and not refers to the values in each cell of the heat map, and that we will be using. So if we will make and not as false, then we will be not seeing any values in our cells. We will be only seeing the color in each cell of heat map. That's why I have made and not as true. Then C map will be cool warm, so that the color will there is a bug. Cool warm, the color will differ from blue to red. Then we have FMT, means the and not values will be in two decimal places. For that I have to take it as 2f, and the minimum value of v min will be 1, and maximum minus 1, and v max will be, these are the minimum and maximum value for and net values that will be present in our cells of heat map, and the maximum value will be 1. Yeah, here we have done. Then the title of our plot will be correlation. Once you have to read the pair plot, you should understand how to read and examine the pair plot and heat map plot, because these are very essential in our machine learning uh, building models. And at the end, plt dot show. Again we got another error. Here it is cool warm. I make silly mistakes in the code. Yeah, let me take it in full screen. So this is our map. You can see diagonally that So first of all, I will say that how to read the heat map. So if the value is positive, that means a particular feature of that cell is proportional to the another feature of that cell. Okay, and if the value is 0 means both features are not related to anyone, and if the value in the cell is negative, that refers to that features both features are reciprocal, means if one increases then other will automatically decrease. So here you can see that each feature is automatically proportional to each other. That's why the value is plus 1 plus 1 plus 1 diagonally. And if you will see that social event attendance, so if you know that extrovert, you can also, it's a basic thing information that extrovert people attend more social events as compared to introvert, whereas the introvert spend more alone time than extroverts. That's therefore these two features will be opposite to each other, means one will increase then other will decrease. So here you can see that it's a negative 0 negative 0.73 value, means both are reciprocal to each other. Likewise you can see for the other values too. So here we have also completed the correlation heat map. And next, uh, here we have ended our first step, that is EDA. Now we will move forward towards data processing. Yeah, so first of all we will do encoding in our categorical data. So we will be using a label encoder for encoding categorical data, as you can see here. But you should know that we cannot use label encoder, uh, a single label encoder function in all categorical data. We have to use a, for each categorical data column, we have to use an independent label encoder function. So for that we will be using for loop to use label encoder in each and every categorical column. Categorical calls lay equal to label encoder tf, particular column will be equal to lay dot fit transform. We will do transforming transform df call. Yeah, so here we have done this thing. Yeah, so we have encoded our columns. And next thing you have to see that if we will move above, and you can see our target column personality, that is our also a categorical column. So we have to also encode this column. For that we have to use a separate label encoder, uh, df target call equal to label encoder dot fit transform df target call. Yeah, so yes, we have also encoded our target column. Now what we'll be doing, we have to handle the missing values. For that we will be using simple imputer method here, a module here, to fulfill our nan or missing values from our first of all we will be handling the missing values on numerical column, then categorical column. Okay. mm, because I will let you know why I am doing separately. So for that we have to import simple imputer uh, from sklearn, from sklearn dot imputer impute import simple imputer. And we have also known that we have to use random forest classifier algorithm for our model training. So here only I will be importing that scalan dot ensemble symbol import random forest classifier. Yeah, so let's execute this cell. Now moving to the other cell. Okay, so num handling uh, nan of numerical column. So num imputer, so simple imputer, it takes an strategy that on which strategy we are filling the data. So basically what happens is, for each column, if we are handling their missing values, then we have to choose an strategy. On basis of that only a particular value will be filled on place of nan. Okay, so the strategy can be mean, median, or we can also use most frequent. Means in all the entries the most frequent value will be uh, mm, replaced by the nan value. So the for numerical column we will be using mean and not median. You can also use median and check after that how your model treats that. And then df numerical, a simple imputer can be used for multiple columns. It is not like the label encoder. Then num imputer dot fit transform df numerical call. Yeah, and here only we will be also handling nan for categorical calls. Okay, so cat imputer, since it's these features columns are categorical in nature, therefore we can't use strategy as a mean or median. That's why we have to use here most frequent. And hence you got your answer that why I'm using simple imputer to handle missing values separately for numerical uh, features and categorical features. Imputer equal to simple imputer strategy. Strategy will be most what will be strategy, yeah, most frequent. And at the end tf categorical calls equal to cat imputer dot fit, sorry, fit transform df categorical columns. Yeah, run this cell. Yeah, so we have run the our cell. Now let's see, does we have handled our missing values or not. For that we will be doing in df.info. And yes, you can see that all the features we have are handled our missing values, and we got 2900 entries for each and every column. As and if you see above, there were differences because there were also some null values, and now there is zero null values for each and every column. So we have successfully handled our missing values. And now we will move forward. And now here the times comes to to split our data set into train and split data. For that we have to concat our all features, means numerical and categorical features. So concat features, let it take its variable name as s, and numerical calls plus categorical column, sorry, categorical columns. And I will show you that what values that does x keep. So yeah, here we got all our features that will be used to train our model and predict the target value, that is extrovert and introvert. Now moving forward, let's see our x head except our target value. Yeah, so here you can see that no categorical value has been left, and as you can see that we got stage fear in 0 1 values and drained after socializing also in 0 1 values. And moving forward we will be splitting our data set now. Here comes uh, x train, x test, y train, y test, and we will be using train test split function, comma, first will be dfx, and here we'll be using personality personality as our target column. We will take test size, I will say 25%, 0.25, and random state will be 40. Now we are going to train our model, so let me write the heading model training. And then as we have visualized and analyzed our data set, and we get to the point that we should use random forest classifier algorithm for training our model in this data set. So let's take that out, random forest classifier, and let's provide some attributes in it. So first of all, since we got 2900 entries of data set, so for that number of trees will be 100 will be good enough. Then estimator estimators as 100, and then due to the overfitting we need that our trees grow fully, therefore the max depth we will take as none. And then to avoid the overfitting in our data set, we will take minimum splitting, minimum sample splits, samples is sorry minimum sample split as 5. Then for few samples there can be very deep trees. To avoid that we will take minimum sample leaf as minimum sample leaf as 2. And then for good classification we will be taking max features as square root, max features as square root, and at the end we will take random state as 44 for the productivity, random state as 44. And you can also change these values according to you. There will be only one change that yeah, so the accuracy of on your side and on my side will be different because of changing the features in your random forest classifier. But that's okay, it's a part of learning. And then we'll fit our data. white train, and let's run it out. Okay, so we got okay, we have missed a comma here. Now it will run completely. So our model has been trained, and let's do the prediction here. Prediction. So y pred will be rf dot predict. We will take all the test cases, yes, and then let's print the accuracy of it. Accuracy, that will be accuracy score, which we have imported previously in our first IDE cell, and we will take here y test comma y predict, and then let's also see the let's also check for the classification report. uh, Classification report, and here we will take y test comma y predict, and let's run it out. Okay, so we here you can see that we got 94 uh, 0.62. I will make a change here. We will multiply by 100 to get the exact percentage. Yeah, so we got 94.62068 accuracy, and that's a very good accuracy score for our model. And if you will make some changes in your feature of random forest classifier, then you will get that the accuracy score may differ every time when you change any feature. So let's also sorry, let's also check for the uh, confusion matrix. So for that we will be plotting a heat map to understand what values we have got here. Figure fixed size as 6 inches and 5 inches. Then SNS dot heat map, and we will take fusion fusion matrix, y test comma y predict, and the next thing we will be taking n naught value, n naught as true. Then c mm, c map will be blues, so all the cells will be in the blue color. And plt dot x label will be confusion matrix and not. Okay, so we got an extra. Yeah, is there any mistake here? No, there is no mistake. As per I get to know, here is predicted x label, plt dot y label will be actual, and plt dot title of our plot will be confusion matrix. Now see our, let's see our plot. It's running. Okay, matplotlib has no attribute x label. Okay, here was a mistake. Yeah, so as you can see that for s0 for 0 you can see that we have predicted 15 times 1. The actual value was 1 15 times, but we have been predicted it as 0. Likewise, for 0 actual value we have predicted 24 times as 1. 1 refers to the extrovert. Okay, so yeah, that's why we got accuracy of 94.62% because of this fluctuation. So yes, this was the end of our video, and in this video we have explored the dataset performed visualization and prepared everything needed for building a predicted model.